Our last speaker is Luis Aguirre, and he's a research staff member here at IDA. He works on operational testing and evaluation of joint C3 systems and major automated information systems. He has a Bachelor's of Science in Life Sciences from the University of Illinois in Chicago and a PhD in organismic and evolutionary biology from UMass Amherst. His collaborator, Dylan Brown, is up here. He's also a research staff member here at IDA. His work focuses on the same topic, in addition to satellite communication systems. And he received his BS in physics from the University of Missouri in Kansas City and PhD in astrophysics from the University of Michigan. Thank you.
Can you guys hear me all the way in the back? Good. Thank you all for sticking around till the very end of the conference. As Elliot mentioned, my name is Luis Aguirre. I'm a staff member here at IDA, and today I'll be sharing the work that we've done to develop a framework for the verification, validation, and accreditation of pre-production software environments for use in operational testing. And this work is a collaboration between myself, Dr. Gillian Brown, and Dr. Allison Goodman. So the motivation for developing this framework comes from the shift in DoD software acquisitions towards agile software development and some of the unique challenges and opportunities that agile brings for operational testing. Particularly as operational testers, we're concerned with conducting testing under operationally realistic conditions. So one tool that can be useful for this purpose is the use of pre-production environments that are representative of the production environments that software will be deployed into. So our goal is to provide a general framework for to help operational testers on their efforts to verify and validate these testing environments. I think to make a case for why using pre-production environments and why it's important to put them through a VBNA process, it's useful to illustrate the difference in testing needs from the agile development model and the legacy waterfall model. So it used to be the case that software for DoD, acquired by DoD, would be developed and delivered to the end user more or less as a complete product, or at least a product that included most of the capabilities that the user would need. And when that was the case, operational testing needs were a lot more clear. You do operational testing at the end of the development before the user gets it. And then you could do follow-on testing depending on if you found any issues. But with the agile model, it's a little bit more unclear how we do good operational testing, because the software is being delivered and in smaller and more frequent, with smaller and more frequent releases. It's generally recommended that that software still goes a full-on operational test when it gets to a MVCR stage, the minimum viable capability release, but it's a little unclear what to do with the smaller releases. How do we put those smaller changes into a operational testing? How do we operationally test those smaller changes? So one of the solutions is to do a lot of the testing, or to do some operational testing in a pre-production environment, pre-production software environment. And just to clarify, when we're speaking about software environments, whether it's a pre-production or production environments, what we're referring to is the underlying infrastructure and on which that enables the software to run. So the hardware that the software runs on, the operating system that it uses, and so on and so forth. Specifically, when we're speaking about a pre-production environment, what we think of as a pre-production environment is an environment that has been created for certain T&E activities that resembles that production environment where the software will eventually be deployed. And a more intuitive way for me to think about this has always been to think of the pre-production environment as a sort of test range for software. And on this slide, I provide a list of T&E activities. Comes from DoD manual I recently issued. And I want to highlight a few of the potential benefits of doing some OT in the pre-production environment. So the first one is that we can actually test these smaller releases without having to organize a big operational test every time that the software is updated, especially for those smaller when the changes are minor. This is also a good place to a good last place to catch any software defects where it can still be a little bit easier and cheaper for the program to address and fix before pushing out the software onto the production. And lastly, the pre-production environment also provides a sort of sandbox where our operational testers can do some things that they couldn't do in a production environment due to the effects that such a test may have on real world operations. And so our goal is the benefit, all of these benefits that I've mentioned are contingent on building a pre-production environment that closely resembles the production environment on which the software will eventually be deployed. So this is where VBNA comes in. We think that a VBNA process would help operational testers to determine whether the pre-production environment that they're using for some operational testing is an adequate representation of the production environment. And for the remainder of this talk and for really for this framework, we're mainly focused on software intensive programs such as business systems and command and control systems. So this is a quick outline of how we see this framework. We broke it down into 3 separate stages: an initial VBNA stage, followed by a period of verification and validation checks, and capped off with what we call a risk-informed VBNA. So most of this talk will revolve around the initial VBNA for 2 reasons. The first reason being that this is where most of the legwork would actually be done, and the second reason is that the second and third stages sort of repackage a lot of the concepts that we'll touch on the initial VBNA. So many of you will be familiar with the term VBNA from VBNA of models and simulations, but I think it's worthwhile to redefine or reframe each of these terms within the context of what we want to VBNA here, which is the pre-production environment. So when we're when we do verification of a pre-production environment, what we're trying to assess is whether a pre-production environment is composed of similar parts as the production environment, and whether those components are arranged or configured in a similar way. For validation, what we're looking for is a demonstration that that software would behave similarly in the pre-production and the production environment. And for accreditation, we don't really talk too much about accreditation in the rest of the presentation, but for this purposes, we want to define accreditation as the official certification that states that the pre-production environment is an adequate operational testing tool under specific case uses. And I want to focus on the specific case use because unless the program is building a pre-production environment that's identical to the production environment, it is very unlikely that we could do all the tests that we would want in that pre-production environment. So the first step in this VBNA is for the operational testers to identify what the goals of the testing will be in this pre-production environment. Here we've broken down the problem into 4 operational evaluation objectives. So essentially, what kinds of questions are the operational testers trying to ask of the software? They're trying to test for functionality or performance or resilience or even the user experience. And once the objectives of the program have been identified, it is then that we can start looking at what components of the environments we're actually trying to compare to make sure that that the pre-production environment is an adequate tool. So for the way we see the verification part of the VBNA is sort of a qualitative comparison between the environments, essentially checking whether the pre-production and production environments share, are they using the same hardware, are they using the same operating systems, is the architecture similar, is the system architecture similar, are they using the same database assigns and so forth. But as I mentioned, it's unlikely that to have a pre-production environment that's an identical copy of the production environment. So we're not actually trying to make sure that to compare every single aspect or every single component of the environments. This will depend largely on the questions that the testers want to ask, their evaluation objectives. To get started, or as a base for what they should be looking for, we do think that at the very minimum, the pre-production environment should be using the same underlying software and the same security measures as the production environment, but everything else or every other component can be assessed based on those testing needs identified in the beginning. And so the next question for me would be, where do we get this data? Thankfully, most of this data is already being collected by the programs. So a lot of the comparison between the environments can be done by doing a side-by-side comparison of the elements documented in several of the documents, official documents of the program, such as architecture diagrams, interface control documents, or ATO packages. For those programs that are mostly using or building software that's relying on cloud resources, the process might actually be even a lot simpler, because a lot of these programs will use infrastructure as code tools, where they will write a script with the exact instructions on what they need from the cloud providers, and then the testers can just compare the scripts for the pre-production and the production environment. The validation part of our initial VBNA is a little bit more involved, as this requires as the validation part requires a demonstration that the software performs similarly between the two environments. So for this part, we're looking for more of a quantitative comparison when it comes to various performance metrics. So things like resource use, response times, latency, throughput, so forth. And here we would use a similar a method of choosing what to compare. We don't need to compare every single one of these metrics. It may just be what you're looking for will depend on what your operational testing needs are. And in this case, we also have data sources that are mostly in place already, or we can use data sources that are already in place. A lot of these metrics in the previous slides come from, or can come from, some of the testing that the program's already doing, such as performance testing. The only addition here would be to add or measure those same performance metrics in the production environment, so we can have a comparison between the two environments. And most of this would be done using performance testing that relies on read-only requests. We can also have a second component to this part that's based a little bit on the observation of real-world operations, particularly for activities that require changes of the database. So if we can collect activity that's been observed in the real world and in operations, and try to capture those activities and reproduce them in the pre-production environment. And so that's the core of our initial VBNA. To summarize, we want to do a qualitative verification based on a qualitative comparison between the environments, and a quantitative comparison for qualitative comparison of performance in the validation of the environment. The second part of the second stage of our framework is something that we're calling a continuous verification and validation checks. And the way I see this is as a mechanism for operational testers to maintain trust in the pre-production environment. So as the programs will develop, they will have to make changes to the amount of resources that they require to run the software in the production. So we just want to make sure that the program maintains a pre-production environment that keeps up with whatever changes they're making to the production environment. And this is a very simplified verification and validation. For the verification, we actually just do basically the same thing that we did in the initial verification. That's because a lot of that process can be automated, particularly when programs are using infrastructure as code tools. For the validation, we'd recommend collecting some of the same metrics, but only a subset, and maybe with not as much frequency as we would do for the verification. Preferably, we would do this, or the programs would do this during slowdowns in usage, such as maintenance windows. And the last part is what we're referring to as the risk-informed VBNA. And in essence, the risk-informed VBNA is we're repeating the same process as the initial VBNA, but this would only be triggered if the results in the previous stage if the results in the previous stage in the verification and validations checks show that as the program has moved on, that the environments are not keeping up with each other. So this would be the point where essentially the program can go back to the drawing board and make sure that they're maintaining a pre-production environment that is a good representation of the production environment that they're deploying onto. And this caps off our framework. There are a few things that I would like to mention in terms of the framework is not fully complete. There are some things that we haven't incorporated yet. There are some things, the most obvious thing is we don't really talk about accreditation. We would like to provide some recommendations on accreditation requirements, but given that there haven't been any programs that are doing this or have done this before, it's a little bit difficult to figure out what exactly they should be looking for, and this will require a collection of case studies as programs use methods like this or use a framework like this. The other issue with developing a framework for VVNA or pre-production environments is that, especially for cloud resources or programs that rely on cloud resources, it can be a little bit difficult to define what the production environment actually is. For example, in hybrid environments where there's a mix of cloud resources with on-premise resources, and even some, for communication systems, instances of edge computing instances. And also other aspects of cloud computing, such as auto-scaling based on usage rates, and even niche products such as functions as service. One thing that we have started working on recently is trying to develop a verification and validation criteria for BVNA and pre-production environments to do some sort of cyber testing. This is something we've just begun, so we hope to make more progress on that. And the last thing is highlighting that the framework as it is now is mainly geared towards information systems, and the challenge that we have ahead is determining whether there are some aspects of this framework that can be transferred to testing of other sorts of programs, such as hardware systems with embedded software that are also using Agile to develop those software components. And with that, I will take any questions. Yes.
Could you speak to where in your framework you might use design of experiments methods for testing software, things like covering arrays?
I think specifically for the verification, I think because we're just getting started and because there's no real framework at the moment to do verification and validation, I think we're trying to getting this off the ground. We first need to do more kind of like simple comparisons. So we're not really thinking too much about the design of experiments. There are some statistical tests that we can do for when we're analyzing and determining whether the pre-production and the production environments are actually similar, particularly for that performance-based metrics on the validation part. Does that answer your question?
But thank you.